Alright, hello everyone. Today we are continuing our work with looking at using the angle pairs we learned in our previous day of notes. So let's go back to the previous day of notes and just review what those angle pairs were. There were four types and they were created if we had parallel lines. So the first one here, if we have parallel lines, then corresponding angles are congruent. Corresponding angles are in that same relative position. So you start at that point of intersection and you move in the same direction, like up and to the right. Or we could go up and to the left. Or we could go down and to the right. Those would be corresponding angles. Now remember, if the lines are not parallel, then our corresponding angles are not congruent. They're still named with the same name. They're still called corresponding angles, but they would not be congruent if the lines are not parallel. If we do have parallel lines, then we also have alternate interior angles that are congruent. Interior means they're between the two parallel lines, and alternate means they're on opposite sides or alternating sides of the transversal. So in this case, one on the left, one on the right. Notice they're not placed here and here. That would be a linear pair because they form a straight line. One angle has to touch one of the parallel lines, and the other angle has to touch the other parallel line. If we have parallel lines, then we find that alternate exterior angles are congruent. So now we are outside of the two parallel lines, one on one side of the transversal and one on the other side of the transversal. And lastly, this was the exception. This is a little bit different. If we have parallel lines, then consecutive interior angles are supplementary. So consecutive meaning they're on the same side of the transversal, and interior, they're in between the two parallel lines. So these are not congruent, but they are supplementary. So we're going to practice identifying and using those angles today. And then a little bit at the end we have a bit of new information. So this example one is really more of a practice. This is something I have you do in class to practice identifying what the name of these angle pairs are. And it's sorted as a puzzle. This is not really an angle name. This is not really an angle name. It's just that we're going to take these letters and put them in the box below and unscramble them to create a title of a poem by Robert Frost. So it says, sort the angle pairs into their types, unscramble the letters in each category to reveal the title of a poem. So for example, you take a look at these two angles, and we don't know if the lines are parallel or not, but that's okay. We're not looking to see if these angles are congruent or not. We're just naming them. We're just classifying them. Angles in this position are outside of the parallel lines, or maybe they're not parallel lines, but outside of the two lines. So they're not interior, they're exterior angles. And you can see one is on the left side of the transversal, one's on the right side of the transversal. So we would call these alternate exterior angles. And there's a box down here for alternate exterior angles. So you would take these three letters, the C, the N, and the A, and put them in here. And then once we get all of the letters in the right boxes, then we unscramble the letters to form a word from each box. Here's just one more as an example. Here we have the letters N and H. You can see how they're both sort of up and to the left of that point of intersection. So those are corresponding angles. Alright, and then you would take those letters and drop them in the corresponding box. So I want you to try this, see if you can classify the rest of these, and then throw the letters in the box. If you can't unscramble the letters, that's quite alright. We're really just focusing on practicing naming and identifying what angle pairs they are. Alright, pause the video and classify these next four. Alright, let's see if we can classify these next four. On the right hand side of this first row, these are consecutive interior angles. On the next row, these are alternate interior angles. Here in the middle we have corresponding angles, and then here we have corresponding angles as well. And I'll let you solve the puzzle. Alright, go down to example 2. So here we have in our diagram lines that are parallel. You see that little arrow symbol that's in the middle of the line as opposed to on the end? The arrow on the end tells us that it is a line and not a segment, but the arrow that's sort of inside, that tells us we have parallel lines. So these two are the parallel lines. There's our transversal. You can see we have these angles 1, 2, 3, 4, 5, 6, 7, 8, and we're going to find the measures of all 8 angles. Now, instead of answering the questions one at a time, a technique that I'm showing you is to go to the diagram first, just fill out everything you can, and then we'll just transfer that information back to answering those 8 questions. So for example, the only angle we know is angle 3, which is 125 degrees. So starting from that one location, can you find more angle measures? For example, we've learned that vertical angles. So vertical angles are congruent, and vertical angles are opposite each other across that X that is formed. So if this is 125 degrees, then here on the left-hand side, angle 1 is also 125 degrees. We've learned that if parallel lines, then corresponding angles are congruent. So that means angle 3 and angle 7 are also 125 degrees. And now you have another pair of vertical angles with 7 and 5. So this is also 125 degrees. So then notice that these two angles are corresponding angles. They're both to the left of that point of intersection. So we now know angles 1, 3, 5, and 7. They're all 125 degrees. There's angle 1, angle 3 was given to us, angle 5, and angle 7. Alright, so now to find angles 2, 4, 6, and 8, we're going to use a linear pair. So take a look at this straight line, and if you take a look at angles 2 and 3, they form a linear pair. They are adjacent to each other, they form a straight line, they have to add up to 180 degrees. So 180 minus 125 gives us 55 degrees. Alright, so if angle 2 is 55 degrees, then angle 4 is also that, because those are vertical angles. Angles opposite each other across that X are called vertical angles. So angle 4 is 55 degrees. Here, angle 4 and angle 8, those are corresponding angles. Or you could use angle 2 and angle 8, those would be alternate exterior angles. Angle 4 and angle 6, those are alternate interior angles. And so we have lots of ways of determining that the others are 55 degrees. So filling that in, 55 degrees for angle 2, for angle 4, for angle 6, and for angle 8. Now notice something that's very interesting here. Even though we had 8 angles, when you have 2 parallel lines cut by a transversal, you only end up with 2 measurements. Right? You've got those 4 that are the 125 degrees, and then you have these 4 that are the 55 degrees. So even though you have 8 angles, you only have 2 measurements to work with. And that's going to be true anytime you have parallel lines cut by a transversal. Right? So just pretend we have a diagram like this. Let's say, for example, that they gave us one of these angles as 100 degrees. Knowing that one piece of information, could you find all 8 angles? The exercise is similar to what we just did. These are vertical angles, so if this is 100, this is 100. We also know that these angles here on the upper left corner of the point of intersection, those are corresponding angles, so they have to be the same. Or we could have used these two, those are alternate interior, those are congruent. And then again we have vertical angles. So notice we have 4 angles that have the exact same measurement. And then you use the same technique to find the missing angle. You look for those linear pairs. These 2 angles have to add up to 180 degrees. So 180 minus the 100 gives you 80 degrees. These are vertical angles. These 2 angles here are alternate interior, so they have to be the same. Or you could use these 2 angles. These are corresponding angles. They have to be the same. And then, again, we have another pair of vertical angles. So notice that with 8 angles, if you have the situation where you have parallel lines, you really only have 2 measurements, 4 of one and 4 of the other. Now again, if the lines are not parallel, then all the angles will be different sizes. But if they are parallel, we see this pattern. That's good to know. Let's turn the page and continue practicing setting up equations and solving for missing variables with some of these angle patterns that we've been looking at. So consider example 3. It says find the value of x. Show all algebra work is a way of saying don't just guess and check. Don't just use it. Don't just find it on your calculator and write down the answer. No, it means set up the equation, and that's important because we're going to be setting up our equation in different ways. Because, again, this is yesterday's notes. Some of our angles will be congruent, but other angles will be supplementary. So we have to set up our equation correctly. For example, here in part A, here's the parallel lines, here's the transversal. We look to see where the numbers are, and those are the angles we're looking at. You can see that these angles are in interior, between the 2 lines, and they're alternating. One's above the transversal, one's below the transversal. So these are alternate interior angles. All right. And so we learned that if we have parallel lines, then alternate interior angles are congruent. If they're congruent, that means they are equal in size. If they are equal in size, we set these angle measures equal to each other. So that's step 1, identifying the angles. Then step 2, build the equation based on what we know about those angles. And then step 3, we can then solve for the variable. In this case, it just says find the value of x. We don't have to plug it back in. So here's part B. Step 1, identify the angle pattern. There's the parallel lines. We have this angle that's sort of up and to the right of the point of intersection. Here's another angle that's up and to the right of that point of intersection. So those are both corresponding angles. So we have learned that if we have parallel lines, then our corresponding angles will be congruent. If they're congruent, they are equal in size, and so we will set these angles equal to each other. So that's step 1, identifying the angles so you know how to build the equation. Step 2, build the equation. Step 3, let's solve. So I'm going to subtract 3 from both sides so we can move the constant terms to the one side, and then divide away the 2. Notice the answer is not 34 degrees. We already have a degree symbol represented. We're just solving for x, meaning what number would have to be placed in here so that this turned into an angle measurement. So we already have the degree symbol represented. This answer is not 34 degrees because this is not an angle measure. It's the value of the variable. And that's true for both A and B. It's not 8 degrees and 34 degrees. It's just regular 8 and regular 34. Alright, in class I like to have this one as a you try problem because see if you can go through and figure out what kind of angle pair we have. So again, pause the video, set up the equation, and work it out. Now the trick to this problem is identifying the angle pair. And these 2 angles are none of the angle pairs we've studied. There's nothing here. And what we have to do then is we have to take this information and transfer it to another angle so that we do have an angle pair that we can use. We could transfer this information in several different ways. We could take this 3x minus 7 and move it down here because these are corresponding angles and we know these are going to be the same. So we could do this. And if we did, we would then have a linear pair, and that would add up to 180 degrees. Or we have a vertical pair of angles here. We could take this given information, transfer it to this location. And if we did that, then these 2 angles are consecutive interior. And we've learned that if parallel lines and consecutive interior angles are supplementary. So I'm just going to make a note here. Depending on which way we transfer the information, we could either use this pair of angles, which would be consecutive interior Or if we had transferred this information over here to the left-hand side, then these two angles would be forming a linear pair. Either way, they are supplementary. Linear pair is supplementary. Consecutive interior angles are also supplementary inside those parallel lines. Supplementary, of course, is they add up to 180. So that means we have to take these two angle measures and add them up. You don't have to use the parentheses here. They essentially go away, but that's what it would look like adding up the two angles to 180. Did you set that up correctly? A lot of times I see students setting these angles equal to each other, and we have to be careful because they are not corresponding angles like how we saw in the previous example. Right? You can see how both these angles are up and to the right. This is sort of up and to the right, but this is up and to the left, so they are not corresponding. They are not equal. Let's combine like terms on the left-hand side. 3x plus 1x is 4x. Negative 7 plus positive 5 gives us a negative 2. Let's move all the constant terms to the right-hand side, so we're adding 2 to both sides. And then divide away the 4, and we get 45.5. So again, no decimal, no degree symbol here, because this is not an angle measure. It's just the value of a variable. Now in each of these problems, we had one transversal. It gets a lot more complicated if we end up with a pattern where we might have two lines and two transversals. Then it's harder to sort through the information that matters. And one of the tricks you might use is to cover up half of the diagram with a piece of paper so that you can focus on two lines and one transversal. So if I was looking at angles 1 and 3, I would cover up the right-hand side. If I'm looking at angles 1 and 4, I would cover up the bottom half of the diagram. So again, I have just two lines and one transversal. Alright, so just be careful of that. And we're going to see that in these next few problems because we have a lot of lines in each of these diagrams, and the trick is sorting through the information. One strategy I like to use is to find the lines that are marked as parallel and just make them bigger so it's a little bit easier to see where those lines are that we're calling the parallel lines. Because if we have angles inside, then that means they're interior angles. And if we had angles on the outside of that, well, that would be exterior angles. And you can see from this diagram we don't have any exterior angles. What that means is we now have lots of potential transversals. Here's a first transversal. Here's a second transversal. Here's a third transversal. How do we know what we're supposed to use? Well, you want to go where the numbers are. So, for example, if you look at this transversal on the far right, you notice that there is no number given us. There's no value of that angle given us. So there's really nothing to use here. Same with this bottom location. There's no angle measure represented touching this transversal. So even though it's a transversal, there's no numbers here to help us out with anything. So just ignore it. Just pretend it's not even there. It's as if you sort of took a piece of paper and covered up that right-hand side. So now take a look at this slanted transversal, and you'll recognize that we have these two angles, the 4x and the 52. Notice that these two angles are touching the transversal, and the 4x is touching the top parallel line, the 52 is touching the bottom parallel line. So when you're picking your two angles, they must be touching all three of these lines. They must be touching the top and the bottom parallel line, and they must be touching the transversal in two locations. So then we identify what these are. These are alternate interior angles. So that means we've learned that if we have parallel lines, then alternate interior angles are congruent. If they are congruent, they are equal in measure, so we set them equal to each other in this way. And we get x is 13. Now we don't have to plug it back in, we're just finding the values of the variables. But let me transfer this information. If we know this angle is 52 degrees, then its alternate interior pairs is also 52 degrees, and that will just help us a little bit. for solving y. The angle with y is on the left-hand side, and that is touching this left-hand side, this left-hand transversal. So just to color code this to kind of keep track of what we're looking at now, I'm using red. So again, here are the two parallel lines, and now we're looking at this leftmost transversal here. So what we're looking at in red is the angle that is touching the transversal, and it has to touch the parallel line. So on the bottom we have this right angle, and on the top, be careful, it's not just this little angle, because this little angle of the 3y plus 2, it does touch the transversal on the left, but it is not touching the top parallel line on its own. We have to use these two angles together to create one big angle. That is the angle we want because it is touching the transversal on the left and the parallel line on the top. So we're going to add these two together, in other words. So then we want to identify what's the angle pair on the left-hand side of the diagram. They're both interior angles, and they're both on the right side of the transversal. So that makes these consecutive interior angles. And we learned that consecutive interior angles are supplementary. So we will add them up to 180 degrees. So we have this angle at the top, which is really a combination of the 3y plus 2 and the 52 degree angle. So all of that is the angle at the top, those two small angles added together. And then we have its consecutive interior pair, this right angle, and they add up to 180. So again, we don't have to put the degree symbol here in our calculations because we'll be solving for the variable, and the variable is just a number, it won't have degrees on it. So let's combine like terms. Here we have a 2 plus 52, that gives us 54. And you might recognize, hey, you know what, we could very easily just move that 90 to the other side. And so we would have a 3y plus 54 on the left equals 90. And we still have to move all of the constant terms, so I'm subtracting 54. So I'm doing this in two steps. We could have done it in one step had we added the 54 and the 90 together a little earlier, but we end up with 3y equals 36, and that means y is 12. So we have our value of x, and we have our value of y. They don't ask us to plug it back in, but that's what it means by showing all algebra work. It means set up the equation and then solve for the variable. Let's take a look at another example. Here's part B. So again, the challenge here is to identify which transversal we're using. First, find the parallel lines. You can see little arrows here. These are the parallel lines. I like to extend them a little bit. Then I can ask myself, okay, what lines are crossing over those two? We have this one, that's a transversal. And we have this one as well, that's a transversal. So we have two transversals. So if I take a look at this slanted transversal, you can see that we do have some information touching the transversal, like we have this y, but at the top side, where the transversal is touching the rightmost parallel line, there's no information here. So this is useless. I can't use that transversal. It won't help me out. Notice that this horizontal transversal is much better because as the transversal crosses the two parallel lines, we do have information, even if it's just a variable. We do have something labeled here and here. So both of these angles are touching the transversal and they're touching the parallel lines as well. So that's good. We want these two angles, and you recognize those are corresponding angles, aren't they? So here we have corresponding angles just to start things off, and that means this and this are the same. So x equals 65. So really no algebra needed to solve that one as the variable is already by itself. So let's just transfer that information over. So 65 degrees is also found here. So now when I'm taking a look at finding the value of y, y, as we mentioned earlier, is touching this slanted transversal, but there's no information up here that would allow us to find a pair of angles. So I'm not going to use an angle pair in this case because there's no information up here where the transversal touches the rightmost parallel line. So we can kind of cover up that part of the diagram, pretend it's not really there, and then just focus on the left side of the diagram. So notice that we have lots of vertical angles here. If this is 55 degrees, then 55 degrees will also be found up above. And we can stop right here. We don't have to go any farther. But just notice we do have other vertical angles. If this is x, which is 65 degrees, then its vertical pair is down here. And then notice if we have y, its vertical pair is found down here. So we can actually just fill in more of the diagram. And then what we want to do now, see if we can find something to help us solve for y on the left part of the diagram. Notice that we have, right here, a straight line, and we know that there's 180 degrees in a straight line. Now we would not call this a linear pair because a pair is always two angles, and here you have 1, 2, 3 angles. So it is not a linear pair, but it still adds up to 180 because a straight line has 180 degrees in it. So we don't have a name for this because it's not a linear pair, but we do have that line which can be thought of as a straight angle. A straight angle has a measure of 180 degrees. So let's add up those three angles to 180. So we have the 65 degree angle, we have the 55 degree angle, we have the y, and they all have to add up to 180. So again, we can take the degree symbol out because we're just solving for a variable, and when we do that we get just a number, and I believe the answer should be 60. So x is 65, and you can see I should not have that degree symbol there. I'm going to scratch that out because x is not an angle name, it's just a variable, and then y is 60. So again, you try this last one here. Alright, identify your two parallel lines, find a transversal, try to transfer information over as you need. So pause the video and try this one. Again, I like to start by identifying those two parallel lines, making them a little bit bigger as it helps me to see where my transversals are and if I have interior or exterior angles. So I'm going to start off with this line. Notice that this transversal here has this angle of 85 degrees and this angle of y degrees. So both of those are corresponding angles because they are both sort of from that point of intersection directly up. So those are corresponding angles. So y equals 85. So that's our first one. And then if you take a look at these two parallel lines and this transversal, notice we have this x degrees and this 45 degrees right here. Those are alternate interior angles. And that means if parallel lines, alternate interior angles are congruent. So no real algebra here to solve, we're just trying to make sure that we can identify those angle pairs. Alright, so as you can see, pretty much all of this took the angle pairs that we've learned from the previous day of notes and just applied them to more complicated diagrams and just kind of thinking through how we might solve for different angle measures. All of that's pretty much review or practice, and so now we're going to finish up with this new piece of information which is on the third page. Now, as you can see, we're still working with these angle pairs. We have something called corresponding angles converse and alternate interior angles converse. So the angle pair themselves is exactly the same as what we studied before, but the converse should tell you something about how these if-then statements are formed. So to make a comparison, let me go back to the notes from the previous day, and we were looking at things like corresponding angles postulate, or alternate interior angles theorem. These started with the if part being if parallel lines. Now if we took these two parts, the if part and the then part, and we switch them around, remember that forms the converse. So it would read, if corresponding angles are congruent, then the lines are parallel. And that's what we're going to see here. So notice that what we're starting with is that we know something about the angles, and then that will allow us to determine if the lines are parallel or not parallel. You'll notice that on these diagrams, there's no arrow inside to tell us if the lines are parallel or not, because that's not what we're starting with. But we do have these little arcs telling us something about the angles, meaning if you know that these two angles are corresponding angles and you know they're congruent, then we can conclude that the lines they touch must be parallel, because the angles can only be congruent if we have parallel lines. So these are the converses of the four statements we just looked at. If two lines are cut by a transversal, so the corresponding angles are congruent, that's the if part, then the lines are parallel. So to word them for our proofs, as we abbreviate them, we're going to say if corresponding angles are congruent, comma, then, and you can either say then parallel lines or then lines parallel. The order doesn't really matter, but that's the key conclusion. Then the lines must be parallel. The alternate interior angles converse says if two lines are cut by a transversal so that the alternate interior angles are congruent, well then what can we conclude about the lines they touch? The lines are parallel. And so we would say if alternate interior angles are congruent, then we have parallel lines. And that's how we'll phrase it in our proofs. Here's the third one, alternate exterior angles converse. If two lines are cut by a transversal, so the alternate exterior angles are congruent, well then what do we know about the lines they touch? Those lines are parallel. So we would say if alternate exterior angles are congruent, then parallel lines. Now you may remember that this last one was the exception. Going back to yesterday's notes, the theorem says if the lines are parallel, then consecutive interior angles are supplementary. So take that if and then part and flip-flop them around, and it reads if two lines are cut by a transversal so that the consecutive interior angles are supplementary. Now there's no way to mark this on the diagram. We don't have a symbol like we had the arc symbol to show congruency. There's no symbol here, so that's why they have a little comment outside the diagram saying, hey, these two angles are known to be supplementary. We would say, oh, these angles happen to be in the location labeled as consecutive interior angles. If those two happen to be supplementary, then what do we know about the lines they touch? We can conclude that they are parallel. So we would say if consecutive interior angles are supplementary, then we have parallel lines. So watch out for that one change right there. It's supplementary instead of congruent. Alright, that ends this days of notes.